Yeah, we get like 40.
Okay, let's go ahead and get started. Chapter 5 or Module 5 is really a summary of everything from Module 1 through 4 combined. It's called coplanar force system. So that means that we're now in 2 dimensions, and from now on out, for the most part, we'll be working in 2 dimensions. We'll get a little bit in 3 dimensions in mechanics and materials, but not in any kind of complex way. So from now on, we're in a single plane. This is a great problem because you have to define the forces in vector form. So I'm looking for X and Y components here. Then you have to define the moments of MC and MG. And then resultant is the sum of these forces. And the couple is what I talked about for like 5 seconds last time. And what that essentially is creating a force couple system is where you create a new box where you have a resultant force, which is the sum of applied forces, and then a moment that represents all of the moments in the system about point O. So this is going to sum the moment of C, the moment at G, and all of the moments caused by the force at A, the force at E, the force at D, and the force at C. So all of these. I probably could have made another point up there to calculate these forces individually, but we'll shove that in ourselves because we know that we'll have to do it. You'll see a very similar problem to this on the homework. That's the first problem. And I'm going to spend a lot of time working this problem in class today, so you can kind of know what the quiz on Wednesday is going to be like. It's going to be all of the concepts that we're looking at in this format. Yeah. The quizzes are structured. This first one's a little bit different because there's not a lot of concepts. It's mainly math. But the way that this is worded is almost identical, except like in sentence form, to how this first quiz is going to be. Find it's the first 20 minutes of class I'll be lecturing, and then 30 minutes will be quiz time. So this first one is going to be a little bit shorter, but there are going to be conceptual questions because I know that this class is not going to, the goal is not for you to be able to work incredibly complex questions. So on the first quiz, there is a couple questions that are conceptually, like, can you find the positive or negative moment? Is it positive or negative? Things like that. So conceptually understand everything. If you're working through the homework problems that are suggested and you're having a difficult time getting through them, that's okay. Like ideally, you would be able to work through all of the homework problems, no problem. But if you're understanding what I'm talking about in class and the concepts, then you'll be able to do fairly well. And then again, on the quizzes, another thing is if you know to ask me for it, I can answer. So if there is an equation that you thought I would be putting on the quiz, but I didn't, just ask me for the equation because I can see that as you know to look for the equation so I can give it to you. And then probably I'll write it up on the board because everyone will want that same equation. Yeah, so very concept heavy, very concept heavy. There is one quiz in dynamics that's more complicated because it's like a buildup of all the first part of the semester. And I'll definitely be pointing that quiz out. And then formatting. What other formatting questions there would be? It's 30 minutes at the end of class. Looks a lot like this. A lot like this. Just, yeah. 3 questions. There's 2 concept questions and then this question that has a lot of parts. So it's not really 3 questions because this is like 6 questions in one almost, but the first 2 questions are much shorter. I also have not been assigned a TA yet, so this first quiz will not be graded in a timely manner unless they are assigned before Wednesday, but I don't know when that's going to happen. I'll keep you updated on the grading. I can go over the solution though, so you can kind of have an idea of where you are. Any other questions on the quiz? Bring a calculator, pencil. No notes. If you think of any other questions that you have, just let me know. But if not, we'll keep going with this problem. So moments, sum of all the moments, and then that is the end of the problem. Be sure to include units. I will be looking at units on your quiz. For the part A, where we are defining each of the moments, these are all given with angles, which is nice. I'm missing a 30-degree angle here. This is 45 degrees and the others are horizontal and vertical. For force A, which is on top, this is 45 degrees. So cosine 45 in the X, sine 45 in the Y. With our coordinate system, positive being horizontal to the right, Y being vertical. This is going in the same way as the coordinate system in the X and the same way as the coordinate system in the Y, therefore it is positive. And I'm pointing that out, not because I don't think you can figure out it's positive, but sometimes it's easy to drop when it's negative. So be aware when it is positive that you're not just forgetting to add a sign, but it is an intentional positive. This is 300 pounds cosine 45 in the X, positive sine 45 in the Y, and then 0 in the Z. For the force of B, that is all the way here on the right, it's 200 pounds and it's exactly horizontal. 200 pounds horizontal, so that's positive 1, 0, 0. For the force of C, or that's moment C, D, force of D, is a perfectly vertical positive force. 150 pounds, 0 in the X, 1 in the Y, 0 in the Z. The last force we have to define is here. F of E, 250 pounds, negative because the X component is going opposite of the positive, so it's going into the negative X direction. The X component will be negative, cosine of 30, and in the same way, the Y component is going in the negative Y direction. So the Y component will be negative. Negative sine 30, 0. For, yeah. You can leave it here. So for this part, you can leave it in this form. You will have to eventually simplify it out. So for organization, you could put it here, but this is correct. Figuring out the X and Y components of the unit vector and which magnitudes go where, a calculator can do the rest. I'm looking for concepts in this class. So this is good enough for that first part. Defining these moments. When thinking about the unit vector, what axis is a moment acting about? Up, so Z, yeah. So Z is coming out of the plane. It is a cross product between X and Y. Cross product always goes in the third dimension. So even though we are in planar forces, so we're looking at coplanar forces, the moment is still in the Z direction because we're looking in 2 dimensions, but we still have to consider that third dimension because that's how the really smart people who figured out math did. They defined it in this way, and that's how we carry on. And if you're smart enough, define it in your own way, but I don't have time for that. So we're going to continue using what has always been used, where moments are defined in the Z direction. So that's 0 in the X, 0 in the Y, 0 in the Z. For this moment here at point C, this is a counterclockwise force, and therefore it is positive. Be sure to know how to figure that out on the quiz. So we have a positive 350 inch-pound moment. The moment at G is equal to 500 inch-pounds, also in the Z direction. This is a clockwise moment, and therefore it is negative. 1 positive, 1 negative. I'll definitely be looking out for those signs when defining these forces. So we've done part A, part B. Before we go to part C, let's find the moment arms. The moment arms are the R cross F moment arms. So we'll find the R. The tail of the R is going to be about 0.0 because that's where we are analyzing the system. The tip of the R vector is going to be at each of the points. For A, the tip is going to be at point A, the tail at O, the tip at E, tail at O, the tip at D, tail at O, and the last one, tip at B and tail at O. Do I need moment arms to the moments? No. I can still evaluate these moments about 0.0 because it doesn't matter where in the plane the moments are. It only matters about what axis. It's about the z-axis. The z-axis could be coming out of the page anywhere. And if that doesn't really make sense to you as to why, you can think about it in terms of units. This is R cross F, which in our case is inches crossed with pounds, and that will result in an inch pound. The entire moment is packaged in an inch pound. These units that we're giving are an inch pound. So it's already been really nicely packaged for us. We don't need to add on another distance. We can just push that moment right onto 0.0 if we would like to think about it as that, and add it up with all of our other moments. So we don't need a moment arm for the moments, only the forces. RA with respect to O, this is where you'll see that nomenclature I talked about coming into play. The first letter is the force, the point of interest for that force, and O is where we're taking the moment about. A with respect to O is in the X direction, positive 12. There's a 12 back there. In the Y direction, positive 24. X12, Y24. That was A. For B, it is positive 24. This isn't a perfect square. It should be a perfect square. All the way base. Then in the Y direction, it is just 12. Both of them are still positive. It's convenient when the point of interest that we're taking the moment about 0.0 is at the bottom left because our coordinate system, we have that also set up to your origin. Therefore, all of our moment arms will be positive. For D, positive 6 in the X direction. For E, positive 12 in the Y direction. Those two will be really nice to do moments about because they are simplified. So our D with respect to O, positive 6 in the X direction. Our E with respect to O, positive 12 in the Y direction. Yeah. X component of the RB with respect to O, 24. It's supposed to be a square, and it definitely realized that I drew it as the triangle. So I guess this should kind of be like here. So it's 24 in the X direction. All the way. So that's a question that you might have on the quiz too, and definitely ask me. And if you get your quiz back and you asked me and I said something and you wrote it down and it ended up getting wrong because there was some kind of miscommunication, let me know. I really care about you understanding it. And if taking the quiz and having a misunderstanding of the problem is what gets it wrong, not really a fan of that. So just keep asking me questions on the quiz. all of the information we have from that figure is now in vector form. If we were coding this, this is the point where we would code all these values in as our given. And then from now on out, we would just write equations and all the math would be done for us. This is our first step. If you're feeling lost on the problem and you don't really know what to do, you can always define the given values. You can always define a vector. You might not know what to do with that vector, but if you see a vector, you can always define it. It's a great first step when you don't really know what to do. Yeah.
So the last what do you do?
Yeah. It's the distance. I'm not entirely sure exactly what you're asking. It's this figure here is the distance between the location of that force at A, and that will give us a moment. And I'll draw the little arrows for each of the moments. After I do that, let me know if you're still having questions of like what this is. Yeah. Any other questions? Yeah.
So for respect to the x component, it's 24.
Correct. It should be a square. It was given. I just wrote it really badly. Adding these forces together, we will take for the x direction, the 300 cosine 40, 200 times 1. For f of d, that's equal to 0. Then we'll take the 250 times a negative cosine 30. That will be our x direction. We won't be able to reference back to that because we're getting so much information here, but you can look at your notes. So for the x, the r of x, so 300 cosine 45 plus 200 times 1 plus 250 times a negative cosine of 30 and plus 0. This negative sign I put in here because that's the direction of the vector. The y component will be 300 sine 45. These are equal to each other. I could have put the same thing in, but I'm going to keep with the correct cosine and sine relative to what angle we were given. Plus a 151 in the j direction, plus 250 negative sine of 30, and plus 0 for both of those for the vectors that were equal to 0. This was f of A, the 200, f of B, f of D, and f of E. You can always work this backwards to make sure that you have all of your vectors in to like check. Yeah.
Do you care if we leave off the zeros?
No, you can leave those off. Yeah. For grading, as long as what you write down is true, I'm good with that. I'll have like my weird additional formatting, like adding zeros for like teaching, but you don't need to add those. Yeah. And the same with like brackets. I don't care if it's round, the little like alligator brackets or square brackets, as long as it's true. Any questions so far? And this is simplified to where our resultant vector, I guess I should have written out the original equation. My bad. F of A plus F of B, adding all these together, F of D plus F of E. This is the sum of Rx and sum of Ry. Rx is equal to 195.62, and we'll just go with the full vector. So that was Rx. Ry is 237.13, and this is all pounds. Notice that there are no inches here. It doesn't matter the location of all of these forces. If we were given that this was 0.0, 300, 200, 150, and 250, this would be true, because that's what we're looking for, is a force couple system where the resultant force is equal to all of these added together.
So it's like saying like when like you're pushing like for D, for example, is like when you're pushing on it, like the entire box movement's not rotating.
The box is moving, not rotating?
Like it's saying like the entire box is moving.
Yes, yeah, yes. We're just looking at like moving.
Gotcha.
And then the second part is the rotating. So then we don't even care at all about like 0.0 except for taking the moment. So it's only rotating. So this is linear translation in the X and Y. For the moment, this is rotation with counterclockwise being positive and clockwise being negative. For a moment, R cross F, this is where Rx Fy minus Ry Fx. I'll have this equation on there. So you can either look at Rx Fy as counterclockwise rotation and Ry Fx as negative, and plug each of the individual component in to calculate the number, or you can go in and manually do it and figure out whether it's counterclockwise or clockwise. We have, yeah, I'm gonna do both ways so you can kind of see how it all fits together. You can choose one way and stick with it for the rest of the semester, but know that when we get more complicated systems, it's hard to not use this and it's easy to drop negative signs. So only manually do it if you are confident you will not drop negative signs. If you're iffy about your negative signs, I would stick with this cross product. So the moments that we are given, this is the resultant moment. We are already given the moment in moment form with the moment at C and the moment at G. Next, we have RA with respect to O crossed with F of A, plus RB with respect to O crossed with R force of B, plus RD with respect to O crossed with R of D, plus RE with respect to O crossed with F of E. Another reason why I like the A cross or A with respect to O is because the letters on the top match for the moments and it's easier to remember for me. That might not be the case for you, but it helps me. Yeah. It is negative. The negative, and this is a great point because the variable, we're adding a negative here. So this M of C is equal to 350, 0, 0, -1. Yeah. So it is negative, but we're adding G. Thank you. 500. So we're adding a negative. And this is an example of keeping the negative sign where it belongs. It would be true to have negative MC where we define MC as 500. That would be true. I would accept that on your quiz. But for learning, when you're not overly comfortable with the material, it's a good idea to keep the negative signs where they belong. So these are nice and easy because we just have single values for them. The RA with respect to O and RB with respect to O, these have X and Y components and the R. And then the forces, E has components in the X and Y as well. We are going to start from easiest to hardest. So the easiest is D with respect to O. All the components are already perpendicular. And then the second ones we'll do is here where one of them is horizontal and vertical. And then the third difficulty is a moment arm with X and Y components and a force with X and Y components. Starting with our D with respect to O. O and D, F of D, R, D with respect to O. This is tip to tip, not super helpful when trying to figure out whether it's clockwise or counterclockwise. I would suggest putting the tip of the R to the tail of the force vector so that when you curve out your forces, it makes a circle for you. And then you can see that this is counterclockwise. The magnitude of RD with respect to O is 6 inches. The magnitude of the force of D is 150 pounds. So our A with respect to O crossed with F of A is equal to a positive 6 inches times 150 pounds. If we were to look at our moment equation here, we see that Rx Fy is positive. And what we have here is Rx and Fy. That's all we need. Both of these are positive individually. Therefore, our total answer is positive, which is nice. So this one's a little bit elementary to do both ways, but we will continue doing that. For the second level of difficulty, we will go with RE with respect to O crossed with F of E. So that's moment of E. Point E, point O, 12 inches, and 250. We know that we need right angles. We could manually go back and look at our vectors or look here and remember that the X component was 250 cosine 30. We're looking at magnitude here. The arrow going to the left has already taken care of the direction. And in that case, we don't really need this anymore because we have the component that's perpendicular. Manually, if we turn this square into a curve, we would see that the force is pushing EO to turn counterclockwise. Therefore, it is positive. The magnitude of the R is 12 inches. The magnitude of the force is 250 cosine 30. And that is our moment. If we were looking at Rx, Fy minus Ry, Fx, we could see that we have an Ry, we have an Fx, we have an Fy, but we do not have an Rx. So we only need this side. When looking at negative signs, the Ry is positive, a positive 12 inches, but the Fx, this is going to the left, which is towards the negative direction. So this is negative, therefore it results in a positive value. So we can calculate our sign manually looking at it to see if the force is pushing the moment arm to the left or to the right, counterclockwise, clockwise, or we can plug in the sign of our equation and the components to get our total answer being positive. That one was a little bit more complicated because it also had a negative sign too. Yeah. Thank you. Yeah.
Is the Fy from the original component or is that?
Here?
Yeah, where do you see that?
Yeah. The generic equation, not looking at like point E, point D, is Rx Fy minus Ry Fx. Our original Re with respect to O was equal to 0 in the x1 and the y. Well, I guess let's just look at the unit vectors for R. And then for the force, we did have x and y components. So there was the negative cosine 30 and the x negative sine 30 and the y. So it did exist. It did exist here, but because the Rx was equal to 0, it doesn't do anything. And that was probably longer an answer than you actually needed, but. Now for B with respect to O. B with respect to O has, moment, B, R, B with respect to O crossed with F of B, O, and point B. In the X direction, 24 inches, even though it's not a square. In the Y direction, 12 inches. And then instead of our R component only being linear and in one direction, the F component is only in the X direction. Therefore, anything in the Y direction, FBY is equal to 0. We don't really even need to know that this is 24 inches. It's nice, but it has no impact on the problem. It doesn't contribute to the resultant force. And because this is a horizontal force, it does not contribute to the moment. What we care about is all of the moment arm that is perpendicular to the 200, which in this case is 12 inches. If we were to turn this right angle into a circle, we would find that it's clockwise and therefore it would be negative. We could also consider that the moment of B is Rx Fy minus Ry Fx and figure out that the Fby is equal to 0. So this is equal to 0. Just because we have an Rx doesn't mean we use it. All we need is Ry and Fx. And even though both forces are positive, our equation also tells us that it will be a clockwise rotation. And that will give us a 0 minus 12 times 200 for the moment caused by the force at B. Negative because it is clockwise, 12 and 200, the 90-degree values. Are you feeling good about that one? I'm getting less confused faces the more we go through this, so that's great. The last one is the most complicated because not only does the R have X and Y, the force has X and Y. Our A with respect to O, force of A. O, A, and F of A. I'm gonna draw this so it's a little bit more of an angle between the two forces. So I'm gonna exaggerate it. It's gonna be a little bit lower than 45 degrees. Point A, in the X direction, it is given to be 12 inches, and in the Y direction, it is given to be 24 inches. This angle is 45 degrees. So the X direction is cosine 45, and in the Y direction is sine 45. There will be two parts to this moment. Moment of A, Rx, Fy minus Ry, Fx. All of these variables have values. If we wanted to, we could break off the Rx, Fy, and then break off Ry, Fx to look at them individually. So Rx is 12, Fy is 300 sine 45, Ry is 24, Fx is 300 cosine 45. Clockwise or counterclockwise, therefore positive. Clockwise, therefore negative. Our moment at A is equal to a positive 12 times 300 sine 45. Negative 24 times 300 cosine 45. This negative is different and it has different origins than a negative cosine 45. So when you have a negative negative, you could distribute out that unit vector negative to make a positive right away, but that does make it a little bit difficult to check your work. That was manually, or we could just use this equation and say, hey, we already have calculated the vector form for force of A and Ra with respect to B. So we can just immediately put in positive 12, 300 sine 45, wait, xy 24, and cosine 45, or you use the equation. Yeah. No. The reason why I would suggest doing the RxFY and RYXF when all 4 of them are there is because you have to do less work. Most likely, if you are going to do it the manual way, you'll do a lot of it in your head, but I can't like project my head on the board. So that's why I wrote a lot of it down. But you can do like a lot of that in your head, and I wouldn't take off any points, even if I said show all work. But for error and sign, it's easier to use the cross product because it's less steps, especially because I will generally ask for you to define all the vectors, so you will already have the vectors there. Yeah, but this is way more than you'll ever need to do. This is me projecting my brain on the page. Maybe it helps. Any questions on that part? So we can go back and bring all of our vectors, our moments that we defined. With our given, well, we're now at the end of the page. Now we're at the beginning of the problem. So we have all of our moments here. For the resultant moment, we are adding moment of C plus moment of G, which are almost basically given, plus the moment of A, plus the moment of B, plus the moment of D, plus the moment about E. This is also, no, this is good, okay. Adding all of these together, plus the 350, plus the negative 500. Your resultant moment is negative 1,597.44 pounds inches. Any questions about this problem? Yeah. Oh, it was asked for. Yeah. There's so for in this context, it's useless because there's not a step after, but there can be steps after. A lot of time when you're communicating a lot of vectors to someone, you don't want to communicate like 60 vectors individually. So you'll just add them up and say, here's like all of them summed together. And then also for distributed loads, a force from a distributed load is a resultant vector, but it's like an integral resultant vector. So like every single molecule is considered because you're handling density, and it deals with that. So in this context, useless. Later on, it'll be really helpful. Okay, that's all I have for today. Do you have another question? You can ask me after. Yeah, that's all I have for today. Be sure to look at the homework for the quiz on Wednesday. Just the first problem with the homework. That should help you get prepared. Yeah.
That ends part in there.
Here?
Yes. No, your final answer. You just want it in that. Are we going to assume it's moments are always in Z direction? Or
Yes. Yeah. Unless we're in 3D, and I don't think like I know I don't ask any questions in 3D. I'm trying to remember the homework. But this is enough for you because I guess I would technically need to
like 0, 0, -1, and I mean,
or just have like here, like that would be proper. But I would accept either. I'm a little bit less strict with moments than I am with everything else.
Okay. Thank you.
Mm-hmm.
Where that
Yeah.
I'm getting 3 is my answer, but I'm getting it.
Okay, something's wrong.
Yeah,
So the moment, the resultant of the moment is like the location cross with F.
Yeah, and we have F.
Yeah.
Right. And I'm assuming the sum of the forces of the moment about this point of the wall is going to be 0, right? So you're going to have 0 is equal to this times this.
Ooh, the sum of, that's only when you're looking at reaction forces, will it be 0. For this, our moment actually is gonna have a value.
Okay.
So that should change up the sign.
Got it.
I just have a dumb question.
Love dumb questions.
My brain just needs to know.
Yeah.
These are arrows that you're doing, right?
Yes,
perfect.
yeah.
Okay.
When I used to draw them like that, but then they would just get like out of hand.
I just wanted to make sure because like when I see them, I'm like, okay, in my brain, I'm like, okay, she's probably doing this, and I'm like,
Yeah,
she could be doing
my
something
little
different,
like
so
wing gets out of hand, so it looks really.
I just have to ask
Yeah.
like, is she actually doing it?
So the last question.
Mhm.
The last one was a part of the,
Or would on here be better?
yeah, part D. So that is literally just finding every single moment with
Added
respect to
together.
0.0 added.
Yes. Yeah,
So
I was looking at it and I got it. We can. Send me an email because that's like a list of things that we could do. But you can either take it at the same time, but like on Zoom, so you're separate, so it's quiet. But it'll be. I like keep on in the chat. Sometimes like people say stuff. And so you do that, and then like you choose which time to send it in, or we can figure out a different time to do it. I think I would prefer to do it at the same time because that would be easier for me and be easier to grade in. And then to submit it, I already have the assignments on Canvas able to like upload. So you just take a picture. And then I would have you like pull up your
Yeah.
Would that be something for or we? It's like kind of nice. I'm gonna have them on Tuesday, Thursday, and I work from home on Tuesday, Thursday now. But I also like, it seems like a lot of my students. So kind of let me know because my schedule is pretty much like everyone's free.
That's why.
So if you're waiting for the person, let me know. I will be online because I work from home on Tuesday. But then like in future, we can like zero time.
Okay, awesome. All right, thank you.
I was just wondering
If it is okay, the quizzes we leave the units like behind, because you did it a few times and then just me. So
Yes, yeah. The first time I'll add them, especially if it's asked for, but I drop them and add them in.
at the end, okay, thank you.
Can you go back to like the very
This part or
yeah, where did
M of R?
yeah, where you grabbing all I think I'm missing something.
I'll just talk for a little bit and let me know. If I-
No, I got all the other ones because these are all the positive. Does that affect these? Because you get all these, but you already found,
Mhm.
which we found the first set. I guess my notes are up, but you write all it out, and then you find the moments. You find these, the vectors, then you find the moments,
Mhm.
and then
The moments are in the same format of those because these are in inch pounds and the moments that we calculated from pound and inches are also in inch
and then you
pounds.
find its relation to that.
Yes, because if you wanted to write these out like in more detail, it'd be the moment force C about 0.0, force G about 0.0, force A about 0.0, force B about 0.0. I was too lazy to write that.
Where'd you get all those from?
Each of these
Yeah.
from the problem statement. If we
I have it.
no, this is fine because it'd be flipping through a lot. Let me just draw these. And-
Okay, I think what I'm missing is why you have to find the positive and negative of them.
Ooh, because you would just get like a massively large number if you added them all positive, but the like end moment after you've considered everything is actually going clockwise.
So once we found all of these, the only reason you're finding the relation to that is to find if it's positive or negative.
Yes.
Okay, that's what I was missing. I thought we were gonna re-add it together. Okay.
Ah, yeah.
I'm sorry.
Do y'all have questions or?
I do. So, hold on. Why does it flip the sign? So
Some case starts.
There's gonna be some moment generated about that random pin. Oh, are we gonna have to go over different joints?
Very simply.
Okay.
Very simply.
Okay. 'Cause I don't remember that at all.
Well, good, because I'll talk about it.
Okay, so there's some, I'm assuming some pin joint in the wall that like whatever
Yeah.
that's gonna be there or whatever. And
I
there's
think you're thinking too well about this so far.
I'm thinking about a lot of
Yeah.
things that are kind of half still in there, but it's
They're
like,
all true, but for this problem, they're not necessarily relevant. Which is
Okay.
like the curse of an engineer because there's so much information. You have to sift out what's relevant right at this moment.
so I know that the 14 and the 16 that I got for my numbers are gonna flip the sign, but I don't know why. Because so the numbers come out to like it's an example problem. Is there a mark right here?
See if those work.
It's like I got home